So today we have a nice geometrical problem. The diagram is on the screen with all the given details. Now the question over here is to find what fraction is shaded. In simple words, you have to find the value of area of the blue semicircle upon area of the bigger semicircle. So this is Anmol Mishra, and now let us see the solution. How can we find the value of the fraction? So first of all, I will start the solution by taking the radius of the semicircles as variable. So as O was the center for the blue semicircle, the distance OQ is ultimately the radius. So let this distance be equals to a variable A, and as M is the center of the bigger semicircle, therefore the distance M to C is radius of the bigger semicircle. So let this be equals to B. Okay, so here we have taken the radius of the semicircles as variable A and B. Now remember, the question was to find what fraction is shaded, that is area of the blue semicircle upon the area of the bigger semicircle. Okay, so now as radius of the blue semicircle has been taken as A, its area would be pi A square upon 2, that is pi radius square upon 2, upon area of the bigger semicircle. So radius has been taken as B, therefore area is pi B square upon 2. Pi by 2 from the numerator and denominator got cancelled out. A square upon B square remains, and that is ultimately A upon B, the complete square. So what we need to find is this fraction, and that has the value A upon B, the complete square. So now our goal is to find the value of A upon B, that is ratio of radius of the semicircles. Okay, so now I will utilize the fact because of which the position of the blue semicircle is described inside this bigger semicircle, and that is the distance OB equals to the distance AB. Now recall that the point B was a tangent point, and as O is the center of the semicircle, OB forms the radius, and as B being the tangent point, the angle over here is 90 degrees. Okay, and also OB is having a length that is equals to the radius of the semicircle, therefore A. And as per the given data, OB is equals to AB, therefore the length of AB would also be equals to A. Okay. Now the distance from A to M is equals to the radius of the bigger semicircle, therefore B. The distance of AB is equals to A, therefore the remaining distance, that is of BM, would be equals to longer minus the shorter. Longer is B, shorter is A, therefore the distance BM is B minus A. Okay, so here we have marked some of the basic things. Now after this we have two methods to get our answer, so let us discuss the first method. So in the first method, first of all, I will draw a line segment joining the points O and M. Now recall that O is the center of the smaller semicircle and M is the center of the bigger semicircle. Now carefully look at the line segment PQ. It is the diameter for the smaller semicircle. It is also the chord for this bigger semicircle. The bigger semicircle is like this way and PQ is like a chord. Okay, so PQ. Now we draw a line segment from the point M to the point O to this chord. Okay. Now as PQ was the diameter for this semicircle and O was the center, the distance OP is equals to the distance OQ. So OP is equals to OQ. Now what if I join the line segment P and M and Q and M? So PM and MQ are equal because they are the radius for this bigger semicircle, center to the circumference. Okay. So these two distances are also equal. So what I can observe over here is that these two triangles become congruent, side, angle, side. This side equal because they were the radius for the smaller semicircle. These two sides equal because they are the radius of the bigger semicircle, and this act as a common side between them. Okay. So now once two triangles are congruent, rest of the things between them become equal. Let me just adjust this middle line a little bit like this way. Okay. So as these two triangles were congruent, rest of the things between them become equal. Therefore, this angle and this angle become equal, and let it be equals to theta. So now what I can say is that there is a straight line, and on top of it we have two angles. So addition of that angle, so 2 theta would be equals to 180 degree, and simplifying this thing will give me theta as equals to 90 degree. So what I can say is that the angle formed at the intersection of the line segment MO and PQ is 90 degree. Okay, now let us utilize this fact. So first of all, look in this right angle triangle, that is the triangle OBM. So the triangle OBM is a right angle triangle at angle B, so angle B equals to 90 degree. The height is equals to A, the base is equals to B minus A. So by applying the Pythagoras theorem, the length of OM would be equals to square root of A square plus B minus A the complete square. Okay. Now carefully see that the angle QOM is 90 degree. Now I draw a line segment joining the points Q and M. So this line segment that I just drew QM is ultimately the radius for this bigger semicircle, center to the circumference. So the length of it would be equals to B. And the angle O is already 90 degree. The base is having a length A and the height. So what we currently found that was the length of OM act as the height. Okay. So in the right angle triangle OMQ, right angle at angle O, so angle O 90 degree, we can again apply the Pythagoras theorem. So the base square, that is A square, plus the height square, height is equals to OM, and that is already in a square root. So its square would be A square plus B minus A the complete square, and this thing is equals to hypotenuse square. Hypotenuse in this right angle triangle is B, therefore equals to B square. So A square plus A square becomes 2 times A square, plus opening this with the identity will give me A square plus B square minus 2AB, and this thing is B square. B square and B square got cancelled out. I can shift this on that side, and on the left hand side 2A square plus A square becomes 3A square, and that is 2AB. Dividing both the sides by A will give me 3 times A equals to 2 times B. Now I will simply divide both of the sides with 3 times B. So on the left hand side 3 and 3 got cancelled out. What we have is A upon B, and that is equals to B and B got cancelled out, 2 upon 3. So recall that our goal was to find the value for A upon B in order to get the ratio. And the complete thing over here was A upon B the whole square, and that was giving us the fraction that we need. So we got the value for A upon B as 2 upon 3. So 2 upon 3 the complete square is equals to 4 upon 9. And that's the answer by our first method. Now let us see the second method. Okay, so this was the first method that we used to got the answer as 4 upon 9. Now let us see the second method. The diagram is on the right hand side. Okay. And the second method, what I will do is I will simply take the diagram and reflex it along the diameter of the bigger semicircle. Okay, so we reflexed the same diagram along the diameter of the bigger semicircle. Okay. Now let us do the same to same labeling. This point was taken as A, this point as B, this point as C, the center of the bigger semicircle as M, the center of the smaller one as O, this is P, Q and R. And in the reflex part, let it be equals to R prime, Q prime, P prime and O prime. Okay. Okay, now recall the lengths that we have got in the first part. So it was already given as a data that OB is equals to AB. So the same thing, O prime B is also equals to AB. And it was equals to the radius of the semicircle that was equals to A. So this is also A. So this is also A. And the radius of the bigger semicircle was taken as a variable B. Okay. Now recall that the distance MA is also the radius of the bigger semicircle. So the distance from here to here, that is of AM, is equals to B. Distance of AB is equals to A. Therefore the remaining distance, that is of BM, is equals to B minus A. Okay. Now further I will add one more variable, that is the distance of RO. I will take it as a variable X. And as the diagram is reflexed along the diameter of the bigger semicircle, the distance R prime O prime would also have a length X. Okay. The distance of OQ and OP was equals to A, that is the radius. Now I am just drawing the complete circle again, and inside this I will put only the required line segment. The first line segment is the line R to R prime, that you can see as a straight line, R to R prime. And then there is a line segment PQ that is cutting it off, so PQ. Okay. And this point where they are intersecting is the center O of the semicircle. Okay. Now the distance RO is been taken as a variable X. This is the distance for RO. What can you say about the distance of OR prime? Now as per the given data, the point B was a tangent point. Therefore these two semicircles are tangent to each other externally. Therefore the center of the first semicircle, the tangent point, and the center of the second semicircle would be in a straight line. So the distance from here to here can be added with this one and with this one also, because that is also a straight line. So the complete distance from O to R prime becomes A plus X, that is ultimately 2 times a plus x. Okay. Now the distance from O to Q and O to P is equals to a. Now from here I can use the intersecting chord theorem. So the intersecting chord theorem says that if you have a circle and inside it you have two chords that are intersecting to each other at any angle. Now because of this intersection they are getting bisected as P, Q, R, S. Then intersecting chord theorem says that the product of P and R would be equals to the product of Q and S. Q into S is equals to P into R. This is what the intersecting chord theorem says. To prove this is also very easy. You can see it anywhere on the internet. It's actually very easy. Okay. So this is the intersecting chord theorem. So the same thing we will apply over here because we have two chords that are intersecting inside a circle. The angle is not required. So the product of x into 2 times a plus x. So the product of x into 2 times a plus x would be equals to the product of a into a. So a into a is a square. Simplifying this thing, so 2ax plus x square would be equals to a square. Okay, keep this as equation number 1. Now I will again take the complete circle, but this time with different line segment. This would be common, that is r to r prime, and instead of pq I will take the line segment AC, that is the diameter for this bigger semicircle. Okay, and the point where they are intersecting is the point B. Now the distance from R to B is a plus x, and similarly the distance from R prime to B is a plus x. So this distance is a plus x and the bottom distance is also a plus x. Now what can you say about the distance from B to C? So remember that from M to C the distance is B. The distance of BM is B minus A. Therefore the distance of BC becomes B plus B minus A, that is equals to 2 times B minus A. This is the distance for BC, and the distance of AB is very simple, that's given as A directly. So the distance of AB is A. So again we have two chords that are intersecting inside a circle. So again the chord theorem, so product of this and this. So A plus X into A plus X equals to the product of this and this, that is A multiplied with 2 times B minus A. So on the left hand side it's an identity, a plus x the complete square, so we will get a square plus x square plus 2ax, and this thing is equals to 2ab minus a square. Negative a square come on the left hand side gives me 2 times a square. Okay, this a square was already present, so I did give it 2a square. Okay, now from the first equation we have the value for x square plus 2ax, that is a square. So x square plus 2ax can be replaced with a square. So 2a square plus a square is equals to 2ab. On the left hand side 2a square plus a square becomes 3a square, and that is equals to 2ab. Factoring out 2 will give me 3 times a equals to 2 times b. Dividing both of the side with 3 times b will give me a upon b as equals to 2 upon 3. So here we have got the value of a upon b, and the question was to find the value of a upon b the complete square. So that would be equals to 2 upon 3 the complete square, and that is ultimately 4 upon 9. So by the second method also we got the same answer. That's an obvious thing, both the methods were correct, so the answer will also come correct. So these were two methods to solve the same problem and to get the final answer as 4 upon 9. The first method was just within the diagram and using the simple Pythagoras theorem, whereas the second method was to just extend the diagram, that is reflexing it along the diameter, and this made the diagram look like a Spider-Man mask or any superhero mask. Okay, don't concentrate on that. So using the reflection we got the chords, and then we utilized the intersecting chord theorem. We got the same value for a upon b, that is 2 upon 3. So this was my way to solve this particular question. If you have any other method other than this, or else if you have any other question that you think I should try, you can comment below. And if it's hard to comment, you can email me, or else you can send it to me on my Instagram. The link is in the description.